Hello everyone, I'm Sebastian Y, and this is Managerial Economics. In this video, I'm going to go through an example of a combined compensation scheme within the principal-agent problem. In the last video, we went through an example where we had a manager who could earn $120,000 worth of profit for the firm for every hour in which they worked. The profit-sharing scheme gave the manager 10% of the profit of the firm. We also gave our manager 8 hours in which to work. Our manager's budget line is going to be M for income equals 8 minus S. 8 is the total number of hours available. S is the number of hours spent shirking, so 8 minus S is the number of hours spent working. And each of those hours earns $120,000 for the firm, and our manager gets 10% of that, so we'll multiply by 0.1. Let's multiply this out. 8 times 120,000 times 0.1 is 96,000. And minus S times 120,000 times 0.1, we get 12,000 S. So far, this is the same as we had in our previous example. We're now going to add on to our manager's compensation a $20,000 fixed salary. They get this $20,000 no matter what they do. So we're going to add that on to our income. And so our new budget will be M equals 116,000 minus 12,000 S. Note that this equation only holds for S less than or equal to 8. Once S equals 8, then the income is just going to be 20,000. This line actually keeps going past 8, but we know that our manager cannot shirk more hours than they have available. Our utility function will be the same as before. U of S M equals S to the 1/3 M to the 2/3. To maximize utility, we're going to calculate our marginal utilities. So marginal utility of shirking, we take the partial derivative of the utility function, so the 1/3 comes down, S to the negative 2/3 M to the 2/3, and our marginal utility of income, again, take the partial derivative, this time with respect to M, we get 2/3 S to the 1/3 M to the negative 1/3. Our marginal rate of substitution is going to be the ratio of these two. Which simplifies down to M over 2S. This part has not changed from our previous example. We're going to set that equal to our price ratio. Remember that for the principal-agent problem, the price of an hour of shirking is the amount of income that you would give up, which is 12,000 in our example, divided by the price of $1 of income, which is just 1. Multiply both sides by 2S to solve for M, and we get M equals 24,000 S. Where things are different from before is that we're going to plug this into our income up here. So we get 24,000 S equals 116,000 minus 12,000 S, and we're going to solve for S. So I'll add 12,000 S to both sides. We have 36,000 S over here. And then divide both sides by 36,000 to solve for S. And this is 29/9, approximately 3.2 hours. If you remember our example from the previous video, our manager shirked for only 2 hours and 40 minutes compared to 3.2 here. Because this manager now gets a fixed salary, in addition to their profit sharing, they have a little bit less incentive to work. Plugging this back into our budget to calculate our income, we get 116,000 minus 12,000 times 29/9, which is going to be approximately $77,333.33. Notice that I used 29/9 in my calculation here, not 3.2, because we always want to use the fraction in any further calculations. It's okay to round when you write out your answer, just to get a sense for the scale of the number, but always use the exact number when doing further calculations. Now let's draw the graph. As always, I'm going to put income on the vertical axis, shirking on the horizontal. Recall that our budget equation is M equals 116,000 minus 12,000 S. If shirking is 0, we get an income of 116,000. Normally, our budget is going to be a downward sloping line all the way down to the horizontal axis, but now that we have that fixed salary, when our manager shirks the entire 8 hours, they're not getting an income of 0, they're getting an income of 20,000 due to our fixed salary. I'm going to mark that 20,000 fixed salary right about there. And this is going to form a kink in our graph. Drawing in our budget, it's going to come down to that kink, and it's going to go straight down to the axis. This is going to give us a trapezoid-shaped budget set. Marking out our utility maximizing point, we calculated earlier that shirking will be approximately 3.2. We're going to find that same spot along our budget line here, and that's going to give us our income, which we calculated earlier was 77,333. We know that our indifference curve is going to be tangent at that point, and so we'll sketch that in, and that's our graph. Overall, this process is basically the same as when we had a more basic compensation scheme. We just have to be careful about how we draw this. The other potential pitfall here is that this is the equation for the line that actually keeps going past 8. And so if you're doing one of these problems, and if you ever calculate an optimal shirking level that is bigger than 8, we know that's not possible, and what that means is that our manager would rather just shirk all day, in which case the answer is just S equals 8, and then the income is whatever the fixed salary would be. That's all there is to this. If you have any questions, feel free to let me know. Thanks for watching.